Okay, we mentioned BEDMAS before, and since we finished division and multiplication, it only makes sense that we start talking about addition and subtraction. Changing your audio. Yeah, I know. It's not like I don't want to make your ears bleed with my taste in music anyway, so we'll leave it at that. I typically will be playing my own music in the morning just while I'm getting my coffee and getting stuff ready. So if you don't like it, then oh, thanks. Appreciate that. I'm an old man, so I don't know how you feel about liking my kind of music, but makes me feel good. I don't know if it makes you feel good. Anyways, let's keep moving. The next section of today's lesson is going to talk about the addition and subtraction of rational expressions. So just like before, I'm going to start by giving you some simpler fraction examples of what you do when you add and subtract fractions. And then we're going to apply that to things with polynomials like x plus or x squared plus whatever. Okay, so just to finish or start off with the title 2.2 rational expressions, this would be part 2. And what is it involving? Adding, subtracting. Okay, so brace yourself. Again, if you want to title your blank piece of paper with that, that would be great. It's for your own sort of safekeeping and stuff anyways. All right, let's get started. Keeping the examples simple so that you know or you can tap into your previous knowledge from even grade school when you're doing fractions. Adding and subtracting. Let's start with similar numbers as we did before. 2/3 plus 4/5. I believe you were taught when you were doing fractions that the denominator has to be the same. In short, the reason being is if I have a pizza that's cut into 3 parts and I have 2 pieces here, I also have another pizza that's cut into 5 parts and I'm dealing with 4 of them. Pizza slices that are cut into threes versus the ones that are cut into fives are different slices, sizes, right? And so if you really want to add fractions, we need to add them based on the same size of slice. That's one way you can think about it. Okay? So if you want to add something with fractions, you need to have the same denominator. You need to cut the pizza into the same number of pieces. So what do? We use our ability to reduce or increase, right? So it's the same proportions, but 3 and 5, we're looking for the lowest common multiple of both of these numbers, right? Here comes your multiplication tables. Which is the lowest multiple of both 3 and 5? This is still 2.2. It's sort of like a second section of it. I know it's a very large piece. The textbook assumes that like working with fractions is all just part of the same umbrella, but I know a lot of people are not happy with fractions really. Uh, brings up bad memories from childhood. And so I'm going to use it as 2 different lessons. Okay. The lowest common multiple of 3 and 5 would be 15. It just happens to be the multiplication of 3 and 5 as well. So if I want 3 to become 5, I'm multiplying the numerator and denominator by 1. That is, I'm doing this 2/3 times 5/5 plus 4/5. If I want to turn 5 into 15, I'm multiplying the top and bottom by 1, so nothing changes, but it's just 3 times 3. 3/3. This becomes 2 times 5 multiplied across 10/15 plus 12/15, and that equals 22 out of 15 pieces. I'll stop right there. Any questions about adding or subtracting fractions? 10 seconds. Going once, going twice. Okay. In the same way, if I were to subtract the same numbers, right, I still need the denominators to be equal. And again, top and bottom, multiply by 5, multiply by 5, this becomes 10. Multiply by 3 and multiply by 3, this becomes 12. The answer to this would be -2 over 15. And notice I'm already starting to skip steps. I'm skipping this portion because I've done this so much in my childhood. I don't want to do it anymore. It's a waste of my ink. It's a waste of my wrist muscles. Okay? I just don't want to do it. So if you can do this, multiply by a 1 in your head, do it. Okay? Once again, 10 seconds. Any questions? How come only the 4 changed? No, the 5 changed to 15 as well. Right? 4 times 3 and 4 times 3 and 5 times 3. They both changed. Unless I'm doing something crazy. Tired Gummy, did I address your question? Oh, okay, no problem. All right, now with this idea of, okay, so when you notice that we are adding or subtracting rational expressions, identify what you have to do. If you're adding and subtracting, the first thing you want to do is factor to make life easy for you, and then make the denominators equal to each other. So, oops. So how about I try to give you a simpler example? We've got, let's pretend we have x plus 2 over x plus 3 added to x plus 4 over x plus 5. Notice how I just turned these 2, 3, 4, 5. I just turned it into x plus 2, 3, 4, and 5. Okay? So these are already factored, or there's no factoring involved. If you want to add them correctly, you need to make them both the same denominator. X plus 3 and x plus 5, there's no fancy, sneaky way of doing it. If I want both of them to have the same denominator, I'm going to have to multiply with each other. So this becomes x plus 5 and x plus 5 plus the x plus 4 and x plus 5 is going to be multiplied by 1, which is written as x plus 3 and x plus 3. In case you're wondering what the heck happened, please note x plus 3 is here, right? The x plus 5 is here. And because I want the denominator x plus 3 to be the same as the other fraction, I am multiplying, let me get the blue. I am multiplying by 1 using the previous denominator right there. And the x plus 5, I want to have the same denominator as the previous fraction. And so I'm multiplying by 1 using the binomial for, that. I hope you understand where this comes from, right? This is I'm multiplying by 1 and I'm multiplying by 1 here. And I'm doing this so that the denominators will be exactly the same. You'll see right now.
Mr. Kim?
Yes.
So in this situation, like 3 times 5 is 15, so it makes sense. But if you had a situation where the lowest common multiple wasn't necessarily the result of the multiplication, would you still multiply them, or would you find the lowest common multiple
Oh,
for
lowest common multiple to make your life easy.
rational expressions as well?
Yes, and I'll give you an example of that. So for example, let's pretend it's like 2 over 10 multiplied by 3 over, let's say, 4, you could make the denominator equal to 40, but 10 could become 20. Oh, sorry, that's an addition, isn't it? 10 become 20, and then 40 can become 20 as well. So you can use a lowest common multiple. Okay. All right, here we go. So from here, the denominator now is a polynomial or quadratic. And then numerator is x plus 2 and x plus 5. The denominator is, I'm going to write x plus 3 first just to make it be exactly the same as the first fraction. And this becomes x plus 4 and then x plus 3. Okay, at this point in time, I just want to point out one thing. When you are adding, you can at least use a different color. Leave the denominator as factor form. However, for the numerator, you're going to have to expand and simplify because it does make the numerator more manageable. It makes it easier to work with. So I'm going to expand the numerator and simplify it. Let me highlight that portion so that you know what I'm talking about, where I'm talking about. This portion and this portion, the numerators, I am going to multiply out, and then I'm going to group the like terms together. So this is x squared, 5 and 2x, and then 2 times 5 is 10. And then that's added to x times x, 3x, 4x, and 12, 4 times 3. So I'm running out of space, but I'll try to keep it steady. The denominator is still x plus 3, x plus 5, x squared plus x squared, 2x squared. 7x plus 7x is 14x, and 10 plus 12 is 22. And lastly, don't ever forget when we're doing rational expressions, go to the original equation. The denominator can't be a negative, so we have -3 and -5 as my restrictions. I'll give you a quick second to sort of copy this through and chew on it and ask some questions. But as you can see, multiplication and division actually seems to be easier because we can cancel things out. For adding and subtracting, it gets a bit messy because it looks like we're making it bigger. But unfortunately, that is in fact the case. You're gonna have to be comfortable with expanding a lot and then grouping like terms. Adding and subtraction will give you some of that for sure. Any questions?
Yeah, I have a question.
Yep.
We
got one in chat too. Go for it.
The step that you took from where you did the green highlighting, and then you did 2 steps to get the final answer. Were both of those steps, did you basically just FOIL?
Yes. So let me use
So you
my
have to FOIL You FOIL x plus 2, x plus 5, and then x plus 4, x plus 3. You just FOIL those two, and then you FOIL the x squared plus 7x plus 10, and then the x squared plus 7x plus 12.
Yeah. I did
Okay.
these two. So that part becomes the left side, and that part becomes the right side. And then I group like terms.
Got it.
Sleepy Toast asks, will we have to factor the numerator now, or will we just leave it in standard form? In the grade 11 level, as far as my class is concerned, you can leave it. However, that's a really good point that you raised, because what if I factored it and I get an x plus 3 or an x plus 5 out of it? You'd be able to cancel out again, right? So you're right. I'll add a little note to this saying, note, you could factor the numerator again to see if x plus 3 or x plus 5 happen to divide out further. Now that's a lot of factoring that I would ask just for one question. And so most likely I won't get you to do that in evaluations and stuff. Maybe on an assignment where you have ample amount of time, I might get you to dig deeper. Put a little note there, like put a little asterisk in your note and tell yourself that, you know, in the future, when you get to grade 12 or so on, in real life, it's not like they don't care about your feelings, right? It may happen. It's very, very possible that it might happen. But for the moment, I'm just here to evaluate whether you can do it and in your skills in adding and subtracting and factoring. So don't worry too much for now. So that's addition. I want to do an example of subtraction for you because I feel like some people might fall into a trap of not doing the subtraction properly when they are applying it to the next fraction. Any questions before we look up an example together? Going once, going twice. All right, I'm going to clear this. And actually, I'm just going to stop share, and I am going to share the same rational expressions exercise that we had before. Let's keep it simple. Let's not do the hardest one. How about we try? I wish I could do a quick vote on Zoom. Number 4 or number 5 seem to be pretty decent. I'm going to do number 4 with you together, and then I'm going to break you up into groups and see if you can, I'm going to say in groups of maybe 3, attempt number 5 using number 4 as an example. Okay, so we'll do that together. That will probably bring us closer to 11:15 or so. And the remaining amount of time you can use as you see fit. And maybe we can start our office hour a little bit earlier. Okay, let's do this. So number 4 states x over x squared minus 1 minus x plus 1. Step 1, just as before, I'm going to factor everything in hopes that it will make my life a little bit easier. And I hope you understand why I'm doing that. If I wanted this to be the same denominator, what would I have to do? Well, it would be x squared minus 1 multiplied by x plus 1. You know what that would turn into? It would turn into x cubed x squared minus x minus 1. It becomes a really, really nasty denominator. So take a look at what I'm doing instead. I'm going to factor first. So when you do number 5, do this as well. X squared minus 1 is a example of difference of squares. So I can just write x plus 1 and minus 1 minus x plus 1. Now look carefully at the two fractions. There's a reason why There's a reason why I decided to factor. It's because I noticed that on the left side and the right side, so the first and second fraction, they both have x plus 1. But what does the left have that the right is missing? X minus 1. What I'm trying to say is this. I don't need to do anything to the first fraction. If I want these two to have the same denominator, all I have to do is work with the right side or the second fraction and multiply it by 1. Remember, the whole goal is to have the denominator the same. So why put more work on yourself? This is why you factor first, to see if you can lower the amount of work you have to do and only work with pieces. All right? Let's keep going. So if this is indeed the easy way to go, this becomes 1 times x minus 1. And this becomes x plus 1 and x minus 1. I'll stop right there to get people to get caught up. And any questions, I'll take them now.
Sorry, when you say that you don't need to touch the first one, is that just because the x plus 1s cancel each other out?
Not cancel. Remember, the whole goal is to have the two denominators equal each other, right? Like if I have 2 over 3 plus 4 over 5, I want the denominators to be the same, so I turn them both into 15, right?
Yeah.
In the same way, if I want these two denominators to be the same, well, I could just take x squared minus 1 and x plus 1 and multiply them together. But what if all I have to do is take what I have, x plus 1, and multiply a small piece to it to make it equivalent to the left one, right? All I'm trying to say is the only thing that's missing between the left fraction and the right fraction is this x minus 1. And so let's bring it in. And I don't need to touch the left side. Does that make sense? I hope.
Yeah, it does.
Okay. Any other questions? All right, following. Now that we have the same denominator, all we have to work with or finish off is the numerator. But please note, this is where a lot of people fall into a potential careless mistake. And what is that? X minus x minus 1. This negative applies to everything in the numerator here. Some people write this, minus x minus 1. But that's not true, okay? This negative applies to the x, so it is minus x. But that negative also applies to everything else inside the bracket, which makes the negative 1 a positive 1. Please be careful. Long story short, the final answer to this is positive 1 over x plus 1, x minus 1, and the restrictions, x cannot be -1, +1, -1. So it's just -1 or +1. Oops. Any questions? Okay, if there aren't any questions, I'm going to randomly distribute you into groups of 3 again. Please use each other as sort of soundboards to be like, okay, let's start factoring. I think that's the way to go. Are you doing this? Are you doing that? I'm not sure if you're able to share screens with each other. I don't even know if you have like a little thing that can help you write, but see what you can do and check your answers together. I will pop in and answer any small questions you might have and then help you out. And hopefully we'll be able to finish number 5 as a class by 11 o'clock. Okay? So breakout rooms, 7 people, no, I think 8 people. 8 rooms assigned automatically. All right, let's go for it. See if you can help each other out. Ah, okay, water made it. Okay. Um, yeah, I just wanted to jump in because I thought okay, water wasn't gonna make it, but do what you can with number 5.
Okay.
Please do what you can with number 5. Just note that the second one is going to be a difference of square. Hope that it makes sense. Okay. Yeah, just give it a shot. Divide your work accordingly if you can, and we'll go from there.
Okay.
Okay.
Great. Thank you.
Okay. I think it's probably enough time.
Mr. Kim,
Yes.
I don't think my breakout room's working
Um. Why? What happened?
because when I try to join, it just looks like a white screen and I can't hear anyone else talking.
Oh, that is really weird. Yeah, that shouldn't necessarily be the case. Other groups, it seemed to work okay. Maybe there was a bit of a glitch, but either way, you know what? Everyone else is in their rooms. We'll use this as our room. How did it go? Or did you not get a chance to do anything?
I started, but
Hmm.
that's it.
No, you know what? Honestly, that's where we're kind of trying to get to. Um, This way, do what you can with the factoring. We'll do number 5 together. I just broadcasted to everyone saying either come with an answer to compare or a question to ask. So,
Okay.
yeah, hired Gummy says also, I guess it didn't really work out. Okay, maybe it was a group room 1 thing. I don't know. Anyways, sorry about that. Okay, I'm gonna close all rooms in 59 seconds. And here we go. Share screen. All right. Number 5. We're doing this one again. So maybe I'll write something on the side. Add sub rational expressions. Factor all polynomials if possible. Number 2, compare denominators and see what parts may be quote unquote missing, I guess. Such a non-mathematical way of expressing it. Number 3, multiply part missing polynomial in the form of with a value polynomial using the value using the 1/1, I guess. And number 4, simplify, expand, and simplify numerator by adding, subtracting. It's the best way I can do it. It's so much more difficult to explain with steps and rules than it is to demonstrate. Someone in chat. Yeah, Taragami, I couldn't hear anyone. I think breakout room number 1 was a little bit off. I'm not sure what to make of it. I apologize for that. I'm not sure what happened. So I just wrote up a couple of steps that you could follow if you're one of those people who like the steps. But for the moment, well, I'd rather it be embedded in you that it just becomes habit for you to always try to factor first and then compare to see what you can do with it. I think part of math is not necessarily memorizing steps, but being able to analyze a situation. It's a very, very good skill to develop. Okay? Because every scenario could be a little bit different, so it depends on your ability to make decisions to successfully solve a question. Okay, so as such, I noticed that the denominators can be factored. I am going to do so. 2, but adds to -3. -2 and -1 will add to -3. And this is a difference of square. I couldn't hear you. What are the main things we are being evaluated on other than tests? So while I go ahead and highlight, I can answer that question. First thing that you're going to be given marks for are unlimited attempt quizzes. So don't let those free marks don't let them escape. Take advantage of it. The second thing you're going to be evaluated on are going to be chapter-related assignments. Sometimes I will give you, typically I'll give you an assignment for each chapter, if not for each concept. And then I am going to have grouped tests. So there's going to be a test for chapter 1, 2, and 3 together. But it's only going to be an hour long, so I'm basically going to be asking you questions on the main types of questions, the main concepts. Okay, I'm not going to give you like 20 pages and you have to do everything in 1 hour. It's going to be short and sweet. And so how you would study for it would be a little different than how you would normally study for a test. What you'd want to do is try to study for like the main concept, like a questions that uses the main concept that you used for that test. I don't have the time to test you on every single one in that test, in that chapter. So that, again, going back, there's a test for chapters 1 to 3, chapter 4 to 5, and chapter 6 and 7. There's 3 big tests, which is going to be like an hour long, plus extra time if you're allowed it. And they're all going to be written in the classroom. If you are a virtual learner, then that morning of, like 15 minutes before the test begins, I'm going to email you a copy, which you are responsible for printing, and then you have to turn that into a PDF when you're done and submit it before like break, like 10:30 or break ends or something like that. I'll give you enough time to print out and scan and give back to me, okay? Because that takes up time. But we'll talk about the details after. Tests are going to be done in class. There's going to be assignments and then the quizzes. Good? Yes? No? Maybe? All right. I see that x minus 2 and x minus 2 are common in both. But if I want these two fractions to be identical, the right fraction needs x minus 1 from the left fraction, and the left fraction needs x plus 2 from the right fraction. Okay, so take a look. I'm going to try to color coordinate to show you where everything's going. Oh, oops, I need black. 3 over x minus 2 and x minus 1. And the right fraction needs x plus 2 from the left. So again, color coordinating. X minus 2 was originally there. X minus 1 was originally there. And the x plus 2, I'm basically multiplying by 1, right? That's x plus 2 over x plus 2 is a 1. So that comes there in the first fraction. Minus x plus 2 and x minus 2. That has always been there. And the right fraction needs x minus 1 from the left. So again, all right, I need highlighter. X minus 2 was originally there. X plus 2 was originally there. But if I want to make the denominators exactly the same, I need x minus 1 over x minus 1 here. So let's do it. The denominator is, remember, because it's multiplication of these binomials, I don't care what the order is as long as it's all there. The top part is 3x plus 2 subtracted by 2x minus 1. Oof. Okay. Why is x plus 2 on top? Once again, let's see, where's the green? Please notice that if I want this denominator and this denominator to be the same, the left fraction has a blue, the right fraction has a blue, so we're good. The left fraction has a red, but the right fraction doesn't, so the right fraction needs the red. In the same way, the right fraction has green, the left fraction doesn't have green. So it needs the green, it needs x plus 2. Yeah, got it? Okay. So we got 3x plus 6. Oops, it's still green. 3x plus 6, negative 2x plus 2. And I'm going to simplify. Oh, I'm so lazy. I don't want to write all the brackets. Ooh, x minus 2, x minus 1, x plus 2, x. So 3x minus 2x, 6 plus 2. There it is. Whew. Oh, almost forgot. Restrictions. Go back to the original, which is right here. What are my restrictions? X can't be a positive 2, x can't be a positive 1, x can't be a negative 2, and then x can't be a positive 2, which I already wrote. So I'm going to rewrite everything in numerical order. There it is. Questions?
When you did the restrictions, which equation are you looking at?
Oh,
As
always,
the original, like quote
yes,
unquote
always
original?
go back to the original just so that you don't confuse yourself.
And which one would that be in the situation?
Well, it would be this one, but it's easy to identify the restrictions if you look at the factored form of it. So just
Okay,
go
so
back to the
basically
original.
any factored form.
Yeah, just not this one though, because it's just too big, right? You don't need
Yeah.
to do that. It's redundant. So go to the factored version of it to help you with the restrictions. Um, do you have to write the restrictions in numerical order? The technical answer is no, but it is highly recommended because that is what we call mathematical convention. Um, it's sort of like one of those unwritten rules of courtesy in mathematics. You could sort of compare it to, you know, when you go to a food court or you go to a restaurant or you go to a food court with your friends, you buy your burger and fries or manchuok or whatever it is at the Eglinton food court, and then you don't clean up. Do you have to clean up after yourself and clear the table after you eat? The answer is no, but it's polite if you do. Will you get marks off? You will not get marks off, unless maybe you have Ms. Jones as your teacher. um, but it is very, it's an appreciated thing. So might as well just get into the habit of it. If you forget, that's okay. But anytime you practice, try to write it in numerical order anyway, since you're already there. Okay? Okay. So that essentially is the adding and subtracting portion. Let's quickly recap. You've done multiplication and division, right? Which forces you to be careful of the restrictions because when you're dividing, you have to use the reciprocal. And also, when you're multiplying or dividing, it means that there's room for difficult factoring polynomials. Like I might give you a tougher one to factor out. For adding and subtracting, I won't give you too complex of equation or polynomials, trinomials to factor. Why? Because there's a lot of multiplying by one that you have to do. There's a lot of these things that will force your, I guess, numerator to get a little bit more messy, right? So there's a lot of work you're already doing. So for me to test your skill, I don't think I'm gonna care whether, you know, I test whether you can factor or not. I want to see that you can add or subtract rational expressions. Okay? So think about how I would think and what the main goal of the question is and show me, demonstrate that you can pull it off. That's your focus. It's a lot of stuff. If you're still sort of shaky on factoring, don't worry about the rational expressions right now. You have to be adept at factoring, so go back and practice that first. The rest of this rational expression stuff will become that much easier if you are comfortable and don't feel stressed when you see a factoring question. Okay? What time is it right now? Okay, it's 11:08. It's 11:10. We're a bit early, but all I have left for you, if you want to stay, is practicing more. All of this is just more and more practice. Let me quickly share. Let me quickly share our schedule. So if you take a look, the factoring quiz is out. We are doing 2.2 together right now. 2.2, adding and subtracting and multiplying, whatnot. Sometime next week, I'm going to set a problem set based on rational expressions for you. So essentially, your goal is to sort of be prepared for that. Next time I see you, I'm going to show you how rational expressions could take the form of even like minor word questions. So in preparation, that's it. Your homework would be to finish off this assignment sheet, or not, what am I saying? Finish off this question sheet and compare your answers with the ones I put up online. If you have any questions, you ought to ask sooner rather than later. And if you are done that, be confident, be proud. Give yourself a pat on the back. Again, small victories, go and reward yourself, and have a sense of confidence or security that you're up to date. You're not falling behind in math class. Okay? Yeah. You have the floor. Are there any questions about adding or subtracting? Maybe you have another example. Are there any questions about what's to come in the future? Okay. I think you might be happy to hear. Here's what I'm going to do. I'm going to be here. If we were in class, the remaining 20 minutes, I think I would give you to try any and all of these questions, number 1 to 7 and numbers 1 to 8. Do so, and then ask me questions if you want. I do expect you to sort of stick around here until 11:30. And yeah, but if you want to take a break or whatnot, if you sort of seem like you get it, you need to cool your head so that you can focus better in about maybe 10, 20 minutes, you can do that too. The remaining 20 minutes is yours to spend as you see fit, but please don't waste it watching YouTube or something. Actually let your brain take a break. And think of how you might want to reward yourself. Okay? I'm going to be here and taking your questions. Paragami, where can we find more practice until we get our textbooks? I believe I put something up on our classroom. If we didn't, then that's my fault. Okay, let's take a look. Classwork. Intro, multiplying, dividing. Yeah, so if you take a look at where you get your handouts, you will see this thing called extra resource. Ooh, what have I done? What have I done? Okay, let's go to it right now. So if you click on the actual post online, you will always see something that says extra resource. It says courseware, CEMC, University of Waterloo. For whatever reason, I think it was to help certain students catch up if they were sort of behind in some of their mathematics. There's also Canadian engineering and mathematics competition or something like that. I forget what the CEMC actually stands for. It might be somewhere here. Center for Education in Mathematics Computing. I was totally off. Anyways, This particular portion of a University of Waterloo will give you an actual video demonstration of certain things, and it gives you a review checking your understandings. And of course, at the very bottom, so this is like a practice quiz. At the very bottom, there's always exercises you can try as well. So here are some more practice questions you can do, even word questions you can do. As you can see, yes, you can actually get some word questions out of this. Answers here and detailed solutions. Just to follow up on Tired Gummy's question, I really don't want you to be overwhelmed by all this resource I'm giving you. It's all there so that you feel more secure, not less secure, okay, or more overwhelmed rather. What I want you to do is practice as best you can and then leave the rest. Okay? I just in this time of COVID, I feel like sometimes you don't feel confident and you feel like there's no other place to ask for help or even more exercise questions to make you feel more confident. So I'm just pouring everything that I have in hopes that it might help somebody. Um, yeah, if you have time, you want to try it, do it. If not, do at least what I'm giving you until you feel confident. Okay. Any other questions? Okay, so then the remaining 15 minutes of time, please stick around in chat and try some of the questions I have assigned on that sheet right here. I have another question. When is our first test? I'm going to go to our tentative schedule. Let's see. Your first test that's going to be in class is going to be after chapter 3. It's going to cover chapters 1, 2, and 3 together, asking you sort of the main points of each chapter because I don't have time to test you on everything we covered. Okay. It looks like our first test is going to be, let's see, maybe sometime in March, like second or even like the week before March break, maybe. But during up to that point, there's going to be assignments and quizzes to keep you, thinking. So you don't have to worry about cramming or anything like that. Just keep up. Any other questions?
I have a quick question about the unlimited quizzes. So like I did it yesterday, and after the first attempt, it like submitted it, like it turned it in for me, and I couldn't do it again until like I unsubmitted it and then did it again. Is that just what I have to do for every attempt?
That wasn't the intention. So the next quiz will go live sometime next week. What I have done is I have opened up the ability to go back. So hopefully this one's the last time you have to do that. The next time you do the quiz, we should have the option of going back. But then once you submit it, it's your final submission. Like you'll only be limited to one submission, but you have the ability to go back after you finish.
And for this first one,
Yeah,
how do I
for this first
know,
one,
like,
just keep opening it up and trying it again. I'll look through all your attempts and just choose the highest one.
oh, okay, got it.
But yeah, you're right. Normally, I should have said it so that you only have one submission, but you are allowed to go back and fix your answers. I'll do that from now on.
So every time we do it, will it tell us like our mark? So
I
that
think
we
it
can
should.
go back? Okay.
I think I set it up so that it'll tell you which questions you actually got wrong.
Okay, and then you can go
Then
back.
you can test it out. So I'll set that up for the next quiz too. Okay. Yep, stick around. Let's put it this way. It's about 11:20 now. I am going to stop recording.